Yes. So last session in the demonstration class, we have come up with a comparative discussion on file system and database. And uh, we have tried to come up even to discuss that how important is database to organize data, right? All these things in my last session, we discussed all these points. OLTP, OLAP, what database definition, logical container, which contains related objects, and that objects include all these types, tables, views, synonyms, sequences. DBMS types are there. HDBMS and DBMS are outdated. The developments are going on only in RDBMS and ORDBMS, right? Today, we are going to learn our first point or first concept, that which are related with the introduction to RDBMS. From there, your subject begins. Introduction to RDBMS, Relational Database Management Systems. Yes. Now, instead of making the total points or and getting confused, what I did is I just make this introduction made available hardly with 4 points. 4 points. You be clear on that. It's more than enough. And even in these 4 points also, lot of other points are there that we don't discuss at this stage. What it is, you'll get to know probably once I get into this, what do you call, total, implementation. Okay, chalo bhai. Now let's go. First point I'll write. First point. What it is? RDBMS equal to R plus DBMS. R plus DBMS. Especially this R is there, R. It stands for referential. Technical word it is. R stands for referential. What is referential? It is one of the integrity constraint. Referential is one of the integrity constraint. So coming classes may we are going to learn about constraints. So in that I'll explain you what is called domain integrity constraint, what is called entity integrity constraint, and then we will learn what is called referential integrity constraint. Till then, just remember the word you remember. Yes, R stands for referential. What is referential? Integrity constraint. And remember, referential is for creating relationships. And what relationships? 3. One-to-one relationship. Second, one-to-many relationship. And third one is many-to-many relationship. In that, remember, we have this for direct implementation. This also we have for direct implementation. And this we have for indirect implementation. Yes, 3 are there. One-to-one, one-to-many, many-to-many. One-to-one is direct, one-to-many is direct, many-to-many is indirect implementation. Indirect. And actually, a broad analyzation is no database software supports many-to-many. Easy to get to know about this point is something you can call no support. Even if you need, indirect support is there. No support. No database software supports many-to-many relationship. One-to-one, one-to-many, very perfect support, very perfect implementation we have. This is one point. Second point. RDBMS has been introduced in the year 1970 by Dr. E.F. Codd. Dr. E.F. Codd. He has introduced RDBMS in 1970. में they introduced. Who introduced? Dr. E.F. Codd. The RDBMS has been introduced in the year 1970 by whom? Dr. E.F. Codd. And he has outlined 12 rules called Codd's rules. And then he mentioned one limit. What is it? Any database software satisfies 8 rules, I mean to say, okay? 8 or 8.5. 8.5. 8.5 rules. Any database software satisfies 8 or 8.5 rules, then it can be considered as pure RDBMS. Now let's compare. Our subject, that is SQL Server, satisfies out of 12, 10 Codd's rules. How many? 10 Codd's rules. Because it satisfies 10 Codd's rules, that is more than 8, so it is pure RDBMS. There is one more called Oracle, which is a product of Oracle Corporation. Even it satisfies more than 8 rules. Almost Oracle satisfies 11.5 Codd's rules. SQL Server satisfies 10 Codd's rules. Oracle will satisfy 11.5 Codd's rules. But both are more than 8, so both are pure RDBMS. DB2, Sybase, Teradata, MySQL, they all are pure RDBMS softwares. Pure RDBMS softwares. Now remember few things what I said you in my today's beginning of session. I said even in this introduction to RDBMS, lot of things are there that we don't discuss today. We just leave them in my coming classes as special topics to be discussed through practicals. Like I just said referential integrity constraint for relationships, but I haven't demonstrated how to create relationships between tables. Then here I said about Codd's rules, but I didn't discuss even a single Codd rule, not at this stage at least, because to understand Codd's rules, you should have a complete knowledge of database, RDBMS. Then it will be easy for you to compare and learn those 12 Codd's rules. Third. RDBMS always presents data in two-dimensional format, that is in rows and columns, refers to table. Yes, two things are there, remember always. In this sentence or in this third point, I use a word presents. Okay, presentation. How do you present your data in RDBMS? I said there, table format, two-dimensional format. Next point, I'll use a word again. I'll use a word. Represents. Two different words, two different meanings, two different approaches. Here I'm talking about presentation of data in table format. And remember, here rows, columns, etc. And remember, what is it? Row, row. You call record. In some softwares, they call tuple, column. In some softwares, they call fields. In some software, they call identifier. In some software, they call attribute. Table. In some software, they call object. In some software, they call entity. In some software, they call relation. Row is called by record tuple, column is called by field identifier attribute, table is called by object entity relation. Fourth rule. RDBMS always supports to represent data in normalized way. Normalized. Word. Represent. Remember this difference. Representation is about designing. Representation is about designing. Presentation is about seeing, viewing data, seeing data, viewing the data, seeing the data. That is presentation. Representation is about designing the database. How do you design? Normalized way. And how do you normalize? Yeah. A table can be normalized in different ways, often called normal forms. And we can call them what? 1NF, first normal form, 1NF. Second normal form, 2NF. Third normal form, 3NF. Boy's code normal form, BCNF. Fourth normal form, 4NF. Fifth normal form, 5NF. Yes. Every normal form is connected by some set of rules again. Yes, 1NF is connected by rules, 2NF is connected by rules, 3NF is connected by rules, BCNF is connected by some rules, fourth normal form is connected by some rules, fifth normal form is also connected by some rules. Do you understand? You have any still questions to ask me on this? Go ahead, please. Navnath and Fagbandro. Yeah, you have any questions to ask me? Go ahead.
No, sir, not as of
You're
now.
clear?
Yes, I have some doubt about this voice code normal form,
BCN.
but we will take it later. Yes.
Yeah. That is all completely coming classes part.
Okay.
Only introductory to what is what about RDBMS. I said a lot of things are there, even in these
Hmm.
4 points also that we are going to discuss through practical. Okay? Chalo, right. Yeah. What about you, Fact Benro? You have any questions to ask me? Am I audible to you? Intro RDBMS 12 PM. Okay. Right. Okay, somewhere in this only I'll complete. Instead of creating a separate file in the same file, I'll just write somewhere here. I'll write here. Yeah, here I'll complete. Yeah. Here I'm going to talk about components of RDBMS. Yeah, let me write here only. Components of RDBMS. Yes. Here only I'll write components of RDBMS. Now, in these components, yeah, components में I'll mention first point. Data accuracy in RDBMS is provided with two concepts. A, data consistency. Second, data integrity. These are the two concepts in RDBMS which will always provide what? Data accuracy. Accuracy. How do you provide? Two concepts we have: data consistency, data integrity. Data consistency, I'll be explaining you with two topics. Data consistency. Two topics. One is under foreign key constraint. One topic. Second, I'll explain you this under views. Views topic. Data integrity, I'll cover in integrity constraints topic. Integrity constraints topic mein I'll be discussing about what? Okay, now next part I'll say. Second part. Set of operators are applied on one or more relations, which always produces a new relation. Yeah. Yes, this is second point I wrote. Second point. What is it? Operators. Every database, every language that we use in computers 100% you could find what operator support is available. Operators support is available, set of operators. We are going to apply. Where you are going to apply? On one or more relations. We are going to apply on one or more relations, one or more tables. What will happen? Which always produces a new relation. Connecting with this particular point, we are going to learn 2 to 3 topics in our subject, SQL Server. Two to three topics are there. Yeah, one among them is set joins. One other is another topic is column joins. We'll discuss this. Practically, we will see. Till then, you remember what it is. Yeah. Lot of operators are there to study in SQL Server. Lot of operators are there. What type of operators? These all are available. You call them as relational operators. You call them as logical operators. You can call them as arithmetic operators. You can call them as special operators. You are provided with set operators. You are provided with negation operator. Lot of operators are there. You are going to apply them on tables. And whenever you apply them on tables, it is going to produce some new tables with the output. You understand? That is the reason why you have been called. Set of operators are applied on one or more relations, which always produces a new relation. You understand? And coming to the most
Yes.
important point, what you study is, remember, collection of objects to store data in collection of objects to present data in rows and columns. It means what? One table also data will be in rows and columns. One table also you have data in rows and columns, and multiple tables also will have rows and columns only. I am not saying like one table will present data in rows and columns, another table will present data in some different format. No, whether it is one table or you have 100 tables, all tables will provide data presentation in which format? Always in rows and columns. Collection of objects to present data in which format? Rows and columns. Objects you call, tables you call, your wish. Already I mentioned there that object is another name for table. Yes, this is the complete introduction of RDBMS. Simple to understand. I said that accuracy of data in RDBMS, we provide with consistency, integrity. I haven't explained anything about it. Operators, I only named them, but I didn't show you how to apply them. I said that collection of objects, that to first point itself, I said that always you present data in database in rows and columns. One table also you present rows and columns. Two tables also you present rows and columns. 100 tables also you provide rows and columns only.
Hello, sir.
Yes, please go ahead.
Mm, can you please brief the data consistency and data integrity?
Hmm. Data consistency. I'll just give you a brief overview.
Mm,
Data consistency is how you describe, how you understand is, if you make changes in one table,
mm,
if you make changes in one table, automatically the other table should also be reflected of the change. You understand? Two tables are there
yes.
called table 1, table 2. You made a change in table 1, automatically table 2 should also be reflected of that change. That is called data consistency.
Okay, so
Hmm.
for the data
Hmm.
consistency, that two tables must be in the relationship.
Yes, correct. Correct. Hmm. That is one point. One point. Second. Data consistency can be even achieved even if you don't have two tables. Single table also, if you have, yes, you can still have data consistency. But for that, you require to have a support of another topic that is called views.
Okay,
Views.
okay. Views is a virtual table, so I know about that.
Exactly. Virtual table, you call them? Exactly.
So in the single table, how we can do the data consistency for the one single
Possible.
table?
You can even single table also. There is 100% support of data consistency. Single table also. But for that, you should have knowledge on something called reflexive relationship.
Flexible relationship.
Reflexive relationship. If you have idea on that, if you have practical knowledge on that, 100% you can justify that even on a single table also you can have data consistency. 100%. I'll show you. We'll learn this topic. Your answer should be always like this. How many relationships your database supports? Your answer should be three. One to one, one
Yes.
to many, and reflexive. One to one relationship, one to many relationship,
Mhm.
and reflexive relationship.
Okay, I have heard about the one to one, one to many, many to many, but reflexive
Reflexive
is
also we will discuss. No problem. We will study. Even that is there in our course also. Even we are going to see that with many examples as well.
okay. And what about the data integrity?
Hmm. Data integrity is applying conditions on columns, applying conditions on data entry.
Okay, so for that we need to constant, right?
Hmm.
So for the column
That is what data
integrity.
integrity you achieve with the data constraints.
Okay, yeah.
Data integrity we achieve with data constraints.
Constant. Okay.
Hmm.
For that, so we need to handle the null values also for the data integrity.
Everything.
Okay, I got it.
Hmm. That's it. This is your complete introduction of RDBMS. That's it. Next class में I'll directly come up with introduction to SQL Server. From there, we are into our
Okay.
subject.
So in this course, are we covering the store procedure?
Yeah, yes. Compulsory. You
And some
collect course
JavaScript.
content, na, Navnath.
Yes, I have.
It will be there, 100% will be stored procedure. T-SQL, may you check. Stored procedures will be there.